Then we need to talk now about the OSI Reference Model. OSI comes from Open Systems Interconnection Reference Model. We were talking previously about the importance to implement the solution, the network solution, based in layers, in the concept of layers, and based in the concept of standards. Why? Because we need that the different end systems and intermediate systems could be provided by different vendors. That's why we talk about an open solution. Then the International for Standardized Organization defines a model, an open system interconnection reference model that is divided in 7 layers, stacked in that way, and called from the low level to the higher. In the first layer, a physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Typically, the lowest layers are used to talk with intermediate systems. The layer at which each intermediate system perform some functions, we will talk about different kinds of intermediate systems. For instance, if the intermediate system perform functions only at the first layer, we'll talk about repeaters and hubs. If the intermediate systems perform functions only at the first and the second level layer, we will talk about switches, bridges, and if an intermediate system perform functions in the 3 lower layers, that is the physical, the data link, and the network layer, we will talk about routers. And in this picture, we see that there are some layers in which the entities talk with their pair entity in the other side, but across the network in what we call an end-to-end communication. For instance, in the case of transport protocols, session protocols, presentation, and application protocols. And what is important to know is that this approach is an approach where the lower layers in the systems, in the end systems, are implemented typically within the operating system, and the 3 upper layers are implemented in the application, where perhaps the application could be developed using some libraries, and the functions from those libraries offer to the application developer different functions from the presentation layer or the session layer. Then what we need to know is that there is a typical division between those layers, those upper layers that are in the user domain, and those lower layers that are implemented within the kernel, that is within the operating system of the end system. In this picture, we could observe that we have different entities from different layers. That is, for instance, the layer N, generally speaking, the layer N-1, the layer N-2, and in that way, the different entities from within a system, the same system, not the different entities, the pair entities between different systems, but within each system, collaborate across service interface. The collaboration, talking for instance in terms of OSI terminology, the interface between one entity and the entity below is performed across a service access point, a SAP. And across that interface, the entity of the layer N give the PDU, the protocol data unit, of the layer N to the entity of the layer N-1, and then for the entity -1, the PDU that comes from the upper layer is called a service data unit. The service data unit will be sent by the N-1 entity, inserted, encapsulated into his own PDU, protocol data unit, of layer N-1, and the entity of this layer will append the header, the protocol control information, that is the header corresponding to his own layer, and in that way the PDU from that comes from the layer N plus the header, the protocol control information of the layer N-1 is in fact the PDU, the protocol data unit of the layer N-1, and so on. The encapsulation process across the different layers is performed. And if we talk about all the different layers of the OSI reference model, we will see that at different layers, that is at the application layer, we talk about the PDU of application layer. Then we receive the data of the distributed application. We append, we add the application header, and after that, the presentation layer entity will add the header of the presentation layer, and after that, the session layer add his header. The transport layer add, for instance, another header that corresponds to the transport protocol, and so on. We will encapsulate the original data that was that the application need to transfer across the network. We add to that data all the headers, all the protocol control information at each layer, until at the lowest layer, that is the physical layer, the information is transmitted across a physical link as a serial communication bit or bit oriented. Typically, when we talk about different PDUs at the different layers, we talk about bits at the lowest layer, that is the physical layer. And we talk about, instead of talking about PDUs at the data link layer, we talk about generally about frames. And at the network layer, we talk about packets or datagrams, depending on the particular network protocol. For instance, at the transport layer, we talk about segments, for instance, and in the upper layers, we talk about typically about application messages. Then I remember you some concepts, for instance, the different concepts related with the interaction with the systems. If we talk about the interaction between an end system and the neighbor intermediate systems, we will talk about an link-to-link communication. Or for instance, between different intermediate systems. But in the case of a communication between end system, we will talk about typically about end-to-end communication relationship or communication exchange. We were talking about the OSI Reference Model, that is the Open System Interconnection Reference Model, that is used to communicate different end systems across a network where within that network we have different kinds of intermediate systems. Then we talk about that the reference model is divided into 7 layers called physical, data link, network, transport, session, presentation, and application layer. But now we need to talk about the specific functions that the OSI reference model assign to each layer. In the physical layer, that is the lowest layer, we define the functions like the mechanical, electrical, optical specification that have to be used in order to communicate across direct links systems that are neighbors, that are very near one from each other. And over that layer, we have the data link layer. Remember that in the physical layer, we transmit typically bits, a stream of bits. In the data link layer, we will transmit frames. That is the PDU, the protocol of the unit, is called frame. In the data link layer, the goal is to communicate systems that are in near locations. That is, are systems that are neighbors. Then what we need to implement as a function is the medium access control. That is, typically we use media. If the media is point-to-point, we don't need to arbitrate or to implement any algorithm to control the access to that media. But when that media is shared, for instance, we need to implement some kind of algorithm to access that media. And that function is typically a function of the data link layer. Sometimes we need to implement other functions. For instance, some error detection. Typically, we need to implement an error detection mechanism in order to determine if the messages are correctly received at each destination. And perhaps sometimes, but is not typically using that layer, some kind of retrieve or retransmission mechanism in order to face some error in the communication. In the network layer, in fact, we implement different mechanisms that permit to exchange messages from one end to the other end across the network. But in fact, is a communication mechanism that is used to deliver the messages from one end to the other, but at any point the protocol conversation is performed between the intermediate systems or between the end system and the first intermediate system at the network layer. One of the functions implemented in that layer is typically in the intermediate systems is the routing of the messages, called typically packets or datagrams, and the routing is based in the use of network address. Then we call typically about destination address based routing. That is routing based in the use of the destination address that is defined, that is coded in the header of the packet. Above the network layer, we have the transport layer. The transport layer is the first layer where the communication is performed end to end. That is from an end system and another system across the network. In that way, we can construct what we need to establish a communication between applications, between distributed application. Sometimes we could talk about the inter-process communication, the IPC, that is a process, an application process running in this system that need to communicate with another piece of that distributed application in that end system, and those processes need first they need to communicate the systems. But if there are more than one process in each system, typically in a multitasking, multi-user platform, we need to perform some kind of application multiplexing. That function then is performed at the transport layer. The application multiplexing is performed using numbers called port numbers, typically. And above the transport layer, the transport layer, in the transport layer, some transport protocol could implement additional functions, like, for instance, segmentation, error control, error retrieving, and other functions that we will see when we study the transport protocols like the UDP and TCP. And above transport, we have, in fact, the application. The application that implement different functions, typically at the layer number 7, we implement the functions that are associated with the application, the distributed application itself. For instance, a mail, file transfer application, or a web application that we use a lot when we navigate across the internet. And there are two other layers, the presentation and the session layer. The presentation layer is a layer that is used to perform the adaptation of the different representations of the different data representations from the different end systems. And then in that case, we use a common or communication representation to exchange, for instance, numbers, text, images, etc. And this is a different layer from the application layer, because those functions that could be used within an application, simply calling the library function where someone else developed that kind of functions in a platform, in a system. And finally, the session layer is used to solve some aspects of the communications. For instance, when an application process call with another application process across the network and use typically a transport session, a transport communication, or a transport connection across the network, the application could use, for instance, more than one transport connection or transport session to establish a communication between those processes. And then we talk about the use of only one session, but that session is performed using several transport connections.